Okay, in this chemistry video, we're going to continue talking about chemical bonds. So previously, we've covered ionic bonds. And if you remember that we've got ionic bonds, covalent bonds, and then hydrogen bonds. Hopefully by now, you know everything you need to know about ionic bonds. And in this video, we're going to talk about covalent bonds. So a driving theme that I want you to keep in your mind still is this idea of the octet rule, right? So atom number 1 and atom number 2, if they want to form a covalent bond, ultimately it's all going to come down to this octet rule that we've described earlier. So learning objective number 1 is how do we form covalent bonds? Learning objective number 2 is how many covalent bonds can carbon form? Carbon, you're going to find, is really the backbone to so much of what we do when it comes to fats and carbohydrates and amino acids and such. So carbon becomes very important. As you recall, the big four are hydrogen, carbon, nitrogen, and oxygen, right? Those are the atoms that make up most of us, most of who we are. And so how many covalent bonds can carbon form? That is going to be one of our learning objectives. And the last one here is what is the difference between polar and non-polar covalent bonds? And so this is going to be a really important theme, this idea of what it means to be a polar molecule or to have polar covalent bonds. And we're going to see that theme all throughout all of physiology. So as we get into covalent bonds, we should recall ionic bonds first. And just to quickly recap without going through everything all over again, remember what happens when we form ionic bonds. We saw sodium and chloride hook up together, but the way that happened is that sodium got rid of an electron. And I use that phrase, one man's trash is another man's treasure, meaning that this electron right over here represents trash to sodium, right? It's getting in the way of him satisfying the octet rule. But chlorine, on the other hand, this guy, is actually sitting here thinking, oh, I need that electron right over here. So your trash, sodium, is actually chlorine's treasure. And when they did this, sodium ended up becoming positively charged, chlorine became negatively charged, and these two opposite charges were attracted to one another, and we call that an ionic bond. So here's the question. Actually, it's not a question, it's just a statement. Some of the language that's commonly used is that we say that sodium donates this electron. So he gives it up. He gives it up. He no longer wants any ownership of that electron. He donates it. If you've ever taken a bag of old clothes or something to Goodwill, you're saying, I don't want this anymore. It is completely yours. I have no more claim to ownership of that anymore. And chlorine then accepted this electron. And in doing so, he's saying, okay, it belongs to me. This electron now belongs to me. So in this slide, you saw terms like, and I don't think I made a big deal of it earlier, but electron was donated by sodium. Here, the electron was accepted. So again, when it's donated, you are no longer claiming any ownership of it, and when it's accepted, you are now claiming ownership of it. And the reason I make a big deal out of that is that when we get into covalent bonds, the word share or sharing becomes very important. So I have an image here, giving something away or donating, and that's the term that I just used. I said donate, right? Or giving away versus sharing. I have an older brother. He's 2 years older than me. And because I'm younger than him, growing up, I was always smaller than him. And so I would often get his hand-me-down shoes. And these hand-me-down shoes were completely given away to me. They were donated. He claimed no ownership over them whatsoever. He said, I'm done with them. My feet are too big. They are now yours, Peter. And so they became my shoes. Again, they became fully mine and no longer his. On the other hand, we also had toys like this, and this was a childhood favorite of mine, Hungry, Hungry Hippo. And I remember at least one, we had a few of these actually. I remember one time somebody gave us this and as a gift to share. Because back in those days, I guess even now, oftentimes like the siblings are given a gift. And so this was for us, me and my brother. And so when it came to this, it's not like he said, okay, the yellow and the green hippo are mine, and then the orange and the pink one are yours. It wasn't that. The whole game was fully his, so that he could play with his friends if they came over, but it's also fully mine, so that I could play with my friends if they came over. And so we shared ownership of something like this. And this distinction, as you can see, is very, very important. So when it comes to covalent bonds, we end up sharing electrons. In ionic bonds, we donated, we gave away electrons, but here we end up sharing. So let's take a look at that and see what that looks like. So chemical bonds, covalent bonds are formed by the sharing of electrons between two atoms to complete both valence shells. So let's look at something like this. Sorry about that. We have a hydrogen atom here and a hydrogen atom over here. So just ignore the rest of this just for a moment, just to kind of keep focus with where we're at. let's go ahead and just block this out so we can ignore that, all right? When you look at something like this, you have a single hydrogen atom here, single hydrogen atom here. You could ask the question, as we did before, is the octet rule satisfied over here? And you'd say, nope. How about the octet rule satisfied over here? Again, you'd say, nope, I don't think so. So one option might be for this hydrogen atom to give away an electron. And actually, in that case, that hydrogen atom will have 0 electrons. And that actually is a thing. That does occur, and we'll see that quite a bit later. But in this situation, so hydrogen's a little bit weird. Sometimes hydrogen just gives up an electron, and it actually satisfies the octet rule. I know that's kind of counterintuitive because we said the outer valence shell layer should be full or have 8. And this is one of those just kind of technically I met the rules, because if I flick away an electron, I have no more electrons. And so now actually you do satisfy the octet rule. So when hydrogen ion gives away an electron, he becomes an ion, he becomes a cation. And so that is a thing. But that's not his only option. Another option is to form bonds with other guys out here. So look at this hydrogen atom who also has 1 electron. So when we see something like that, this guy is saying, look, I got 1, you got 1. Why don't we hungry hippo this thing? And so why don't I give you my electron, but you give me your electron? I take that back. I shouldn't have used the word give. Take that back. How about I share my electron with you, and you share your electron with me? And when that happens, look what happens here. So now see this electron over here at the tip of my cursor and that electron at the tip of my cursor? This hydrogen atom on the left has full ownership over both of those. And this hydrogen atom on the right has full ownership over both of those. Just like my brother and I both claimed full ownership over this thing right over here. Just like my wife and I claim full ownership over our car. It's not like I own the front half and she owns the back half, or I own the inside, she owns the outside. We are both on the title. We both own it fully. So this is what we see here. Now, what do? In sharing, we satisfy the octet rule. Now, let's pretend there was like, you know how the IRS sometimes audits people to look at their finances and taxes and things? Let's say there's a chemical auditor that runs along and says, hey, you, right there, hydrogen atom on the left, do you have a full valence layer? And he says, yep, I do. I got 2 right here in my valence layer. Because remember, he equally owns them both. Auditor comes to this hydrogen atom on the right. Hey, what about you? Do you have your valence layer completely satisfied? And the answer is, yeah, I sure do. Both of those are satisfied as well. Okay. Now, we see multiple examples of something like this. Here's another one with oxygen atoms. Oxygen ends up having 2 open spaces in lane number 2. Okay, so there's 2 open spaces. Remember that it can accommodate 8 electrons. There's only 6 in there. Same thing with this guy over here. So they actually end up sharing, hey, let's share 2 of our electrons each. I'll share 2 of mine, you share 2 of yours. So then when that auditor comes around, I have a full valence layer over here on the left. I have a full valence layer here on the right. So that's equal sharing. And you can actually see if this is sharing a single electron, this is sharing 2 electrons, this is sharing 3 electrons. So this would be called a single covalent bond. This is called a double covalent bond. This is called a triple covalent bond. So all those possibilities exist. And the last possibility that I want to talk about is this guy over here. So here's carbon. How many electrons does carbon have in its valence layer? Well, it's got 4 electrons in its valence layer out there. So how many does he want? He wants 4. Now, you could say, well, carbon, do you want to just become an ion? You can dump all 4 of these and become a positively charged cation, but that's a +4 charge, and that's something we're just not going to see. What carbon is much more happy doing is he's much more happy sharing these. So this electron right over here, if you think of this as a clock, and we call this the 12 o'clock position, that electron in the 12 o'clock position says, hey, carbon says, hey, this electron in the 12 o'clock position, why don't I share that with you, hydrogen? This at the 3 o'clock position, I'll share that with you. This at the 6 o'clock, I'll share that with you. And this at the 9 o'clock, I'll share that with you. And what we have here is that all 5 players here, each of the 4 hydrogen atoms, as well as the single carbon atom, now have stable, fully filled outermost valence layers. So their octet rule is satisfied in all conditions. So that is a covalent bond. This slide is just showing you, again, this is carbon again. It's the exact same thing we just did down here, just kind of a zoomed in view. So take some time to look at that. The reason I included this picture here is that, again, you see the sharing of electrons. So carbon has 8 in its outer layer, and hydrogen has 2 in his outer layer. Okay, carbon's outer layer is lane number 2. Hydrogen's outer layer is lane number 1. What I wanted to show you though here was the shorthand for how we write this, because from here on out, really this is how you're going to see things depicted. The convention, meaning this is what a chemist agreed upon a long time ago, is to draw a straight line like this. When you draw a single straight line, that means it is a single covalent bond. So carbon forms 4 covalent bonds. There's one over here, one at the 3 o'clock position, one at the 6 o'clock position, and one at the 9 o'clock position. So carbon forms 4 covalent bonds. So how do we form covalent bonds? We form covalent bonds by sharing electrons. How many covalent bonds can carbon form? It can form 4. So the next question that I want to ask you, and it's something that I had mentioned previously in lecture, is that, well, what about strength, like relative strength of these things? We talked about ionic bonds being pretty strong, but covalent bonds themselves are actually very strong. They're much stronger than ionic bonds. And I want this to make sense to you. Look, if your friend comes along and says, hey, I want to start a hot dog business or an ice cream business, can you help me out? And let's just say you're wealthy and you say, you know what? Look, here is $20,000. It is yours. No strings attached. There it goes, right? So your buddy takes that $20,000 and starts an ice cream company. And let's say things don't go well, a recession hits, and the ice cream store shuts down. It stinks. But from your perspective, you haven't lost anything. You already gave away that money, no strings attached. Your buddy, it just didn't work out. It is what it is. On the other hand, if you say, hey, let's go in together. I'll put in 20 grand and you put in 20 grand and we have co-ownerships. Now we share ownership of this ice cream store. As you can imagine then, like closing down that store or separating it out, it's going to be much more painful, much more complicated, much more complex, because there's now these two people in this shared relationship. So when you start sharing things together, stuff becomes much more difficult to dissolve than if you were just to give stuff away. Okay, so that's the idea of a covalent bond. Now the last thing that I want to mention here then is this. What are the 3 types of bonds? We did this: ionic, covalent, and hydrogen bonds. Well, all I want to really introduce to you then is and we're not going to get to that last learning objective in this video. I'll do it separately. What is the difference between polar and non-polar covalent bonds? I'm going to talk about that separately, but what I want you to see here is that even though, yes, ionic bonds, covalent bonds, hydrogen bonds, these are the 3 types of bonds, the reality is when we have covalent bonds where you share electrons, there are 2 flavors of covalent bonds. There are non-polar covalent bonds, and then there are polar covalent bonds. And only by understanding polar covalent bonds can we then get into talking about this last category of bonds, which is hydrogen bonds. So again, these are the 3 types of bonds: ionic bonds, covalent bonds, and hydrogen bonds. All I'm really saying to you is that when you understand the different flavors of covalent bonds, that is what allows you to eventually form hydrogen bonds. So this might be 1, 2, and I put number 3 over here. This might be a more accurate kind of visual depiction of how these bonds work. So let's close this out. We talked about covalent bonds and sharing electrons. We talked about forming 4 covalent bonds for carbon. And learning objective number 3, I'm going to pick up in a follow-up video. And we'll end this one here.